Hello, my name is Mario, and I'm going to be doing maybe a non-conventional crash course for you in Elm. I work at Travelport Locomote. Travelport is one of the 3 major GDSs in the world. Hands up if you've ever taken a flight before. Anywhere, 1 in 3 chance we sold you that flight. Locomote, what we do is we do corporate travel. So those of you that work at a big corporate, awesome, come and talk to me later. We have a great product for you. But yeah, we do corporate travel management, and we've been acquired by Travelport. So as you can probably tell by the accent, I'm not English or British. I come from Australia, and our company was started in Melbourne. But with the acquisition, I now live and work in London. You can find me on GitHub. My handle is Super Mario. That is my actual real handle. So the goals for what I'm going to do tonight, I was originally thinking of doing the same format that we do at the Elm London Meetups, which is to actually do a code night. You pull out your laptops, you actually work on stuff, people get in different groups. Either you're going from scratch and I'm doing a from scratch tutorial, or you're working on projects, or you might be advanced and helping with open source stuff. But I thought, given that I've got a room of presumably JavaScript and React experienced developers, the more that I thought about it, the more I thought about my own journey into discovering kind of Elm and functional programming, and the things that prevented me from understanding the value of those things to myself and what they would give me in my kind of day-to-day work. And I thought it might be more valuable if I gave you a swathe of those kind of things, because I found those really hard to find online. I mean, you can troll through lots of blog posts and things and try and scrape things together, but until you've really kind of tasted Elm and functional programming for yourself, it's really hard to understand some of those concepts. So I wanted to maybe instead give you a little bit of a teaser of those things that you might not find so easily, and then give you the resources, of which there are plenty of, for you to just learn, like Elm syntax and stuff. So I'm going to try and cover things that might not be obvious. I'm still going to go through a little bit of Elm, so you've got a bit of grounding, but I'm going to talk about some awesome things that, that exist in the Elm community that may not be obvious straight away. I'll talk about some pitfalls, and then I'll give you some references for more stuff. Cool, so this is an Elm app that you're currently looking at. Some of you are still joining. So let's just start it really easy. How are you feeling? Everyone's feeling good, hopefully. Awesome. No one's feeling bad, that's great. JavaScript experience. 0, starting, confident, or pro. Pro meaning you work in JavaScript professionally. Okay. So we've got some people that are 0, some people that are starting. This is going to be awesome for you. For the rest of you, you've got prior knowledge that's going to hold you back. I'm just kidding. Elm experience. How has your Elm experience been in terms of exposure or reading or anything? Awesome, we have some Elm developers here. Most of you 0. Okay, great. So hopefully for those of you that are 0, this will be informative and useful and help you understand, one, is Elm something that you're interested in investing your time in? And secondly, what it might give you generally. Okay, cool. So normally what happens with this is I go through a set of live slides, and you've got on your devices a set of reactions, so you can give me like, you're okay or you're confused, thumbs up, thumbs down, thinking face, falling asleep, or bookmarks. And then at the end of the talk, you can put your email address in and get all that stuff back. It sounds really awesome. Except I'm not going to give it to you because I didn't get to prepare these slides in the software. So we're not going to use this. I'm going to step out of it. But this is more just to give you an idea that this is an app that I've used in past talks. If you look at the Elm Europe conference, you can see me doing it live on stage, engaging the whole audience. And it's something that I've tried for a number of years to build in lots of other things. And I always kind of got to the point where I just couldn't keep pushing further. The complexity in whatever language I worked in really, really held me back. And I think this is probably my best testament for myself personally of what Elm can give you as a developer, because this is the first time I've actually been able to succeed with a project of this kind of scale. So anyway, let's run through the presentation. You can come talk to me afterwards if you want to know more about the Elm app software. So I'm going to avoid these things today because I think that there's better resources than me speaking to you for finding that stuff. So learning detailed syntax, FP concepts as a whole, and looking at comprehensive code examples, it's probably better off in your own time and at your own pace. So I'm going to avoid that kind of stuff, but I will give you things that you can look at afterwards for diving into more detail on those things. So what I am going to go through is I'm going to give you a high level of what is Elm. I'm going to try and disambiguate some stuff that, in my opinion, I feel you might run into if you try and learn it yourself. We'll run through some code, but at a very basic level. And I'm going to run through the Elm architecture, which I think is probably one of the big tripping points that people run into. This question of, is Elm a library? Is it a language? And trying to figure out what it actually does and how you do things. I'm going to try to talk through some awesome things, at least as far as I find them. Roughly talk about how do I use Elm at work, which may be an interest point to some of you, and I'll give you some caveats that I found for myself personally. Awesome. Okay, what is Elm? So by its own admission, this is on the top of the Elm site. Elm is a delightful language for reliable web apps. You can generate JavaScript with great performance and no runtime exceptions. That's almost guaranteed. So in more detail, it's a functional language. It's statically typed, but it has type inference. So if you don't want to write types, you cannot. And Elm will still figure out the types for you up until a point. All data is immutable. So there is no such thing as immutable value or reference or object in Elm. Everything's immutable by default. That's part of the language. You can't opt out of that. All functions are pure, which means that every piece of code that you ever look at in Elm, the answer to the question of what does this code do, the answer is nothing. It takes inputs and it returns a value, but it won't make any effects. It won't change anything in the outside world. It won't ask the outside world of anything. It will literally do nothing. So every line of code in any Elm code base you ever look at has these two guarantees. Null, undefined, and exceptions don't exist. They're not part of the platform. They're not part of the language. You can't type null and have it compile, and nothing within your Elm code can throw an exception or give you back a null. So those kind of things are removed from the language. So these are all rather intentional choices, and they have some really, really interesting implications. When you don't have these kind of things in your, or rather, when you have these kind of guarantees in your language, it actually comes out to be a very, very interesting subset of the kind of programming that you may be experienced in already. So to answer the question of exactly Elm, library, this kind of gets confusing when you start looking at stuff online. If you're familiar with, how many of you are using this kind of stack or something loosely related to this? Yeah, cool. So you get really excited, you want to start with JavaScript, like, right, how do you install packages? Oh, you can't. You got to get NPM. Right. Okay, now I have NPM, like, how do I bundle stuff together? Like, you can't. You got to get Webpack. Cool. And then, React at the moment, you're all here because this is Reactivate, but this is, a more recent paradigm. Before there used to be many other choices, and Spine and Backbone, and more modernly, I guess, Angular as a competitor, but there's a lot of different options there, so you have to pick one. Maybe you pick React. Then eventually you get to a point where you've got too much local state and your components are trying to send stuff everywhere, and you're like, how do I solve this problem? And you go, oh, Redux, so you learn Redux, you bring that in. Now you've got this problem where you add a new action in Redux, and now you don't know all the parts in your code that need to be updated. So maybe you get something like TypeScript or Flow to bring some level of kind of checking to figure out, I've added stuff here and now my code breaks over here. So you kind of bring that into the language. Then you get to the point where you're like, mutable references are really killing us. We're passing objects and accidentally setting methods on them and losing control of our state. So you go, well, maybe we need to bring immutable JS into the stack. So what's the experience like when you start Elm? Well, you go, well, how do I get packages? Well, that's built into Elm. You go, cool. So how do I get all my files compiled into a single version? That's built into Elm. You go, okay, so how do I actually architect my code? How do I do the view layer and all that kind of stuff? Well, that's actually built into Elm. So you go, cool. So how do I manage my state when it gets really big? That's built into Elm. What about type checking and flow? That's built into Elm. And immutability, as I mentioned, is also built into Elm. So the analogy I've been trying to use recently for this is when people say, oh, well, it can't be a language, it has too many features. It would probably be, I'm assuming, similar to originally when memory management was all manual, and you were a C developer, and something like JavaScript came along, and they're like, we have automatic memory management now. And you're like, so that's a library? You're like, no, it's a language feature. And like, that can't be a language feature, like that's too featureful. So this is kind of the same in that same sense. So when we say that Elm has these things built in, it's not built in as a library that you use. It is actually the language. So there's only one architecture in Elm. It's called the Elm architecture. And there's only one way to structure that initial set of code, and that's all baked in. All the libraries that you build in are for various other bits and bobs around. Is that making sense? Getting some nods, lovely. Now, it's not all in isolation. There is kind of like a lot of cross-flow, and lots of the stuff that's in that React stack, if you're already familiar with it, lots of stuff in Elm will just seem really, really natural. So this is just a quote from the Dan Abramov, the author of Redux, who has quoted as pulling certain ideas back from Elm. So if you use Redux, you're actually using a subset of the same kind of function that operates in Elm. So that kind of stuff will come natural to you. The difference, I feel, though, is that here you've got a lot of disparate components with lots of different authors, different styles, and different integration points. Whereas in Elm, the whole ecosystem is built around the premise that the core language has these functions. So there's a huge amount of effort put into them working together really, 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 really nicely. So a lot of the pain points that you may see on the left-hand side, when you kind of come over to the Elm side, my experience has been that those pain points are either way reduced or just non-existent in that kind of environment. So let me dive a little bit deeper into that. Side note, let's just take a slight detour, and then I'll come back. This is a personal bugbear of mine, and it maybe it won't be the same for all of you, but it really impacted my ability to learn functional, because when I came up against these two things, I was really defensive of my existing experience and a bit insulted that there could possibly be something that I didn't already know in programming. So for me, it was really humbling having to probably battle through a year worth of self-learning before I got kind of past these concepts. And I think that they're needlessly complicated. Especially, has anyone here tried to learn Haskell or Idris or any other kind of functional languages? Well, I'm hoping your experience is better than mine, but like space burritos and homomorphisms over functor monads, and it's kind of like the mathematics and the language and the kind of tone of that community is really difficult to approach. So I just wanted to kind of debunk two things that hopefully will help you separate hype from understanding a little bit more. So two things: unbreakable and functional. So what do we mean when we say breakable? Yes, I know it was a bit of a clickbaity title saying building unbreakable software. I'm going to give you two statements. First statement being is the sky is green. Most of you probably think that's wrong. But like, what if we're writing a computer game, and maybe the sky is green? Or what if we're in the northern hemisphere and it's nighttime, so the sky's green for those reasons? Might be wrong, might be not. Like, this is about semantics, right? This is what our job as programmers is, to take models of the real world and understand their semantics and then emulate them in code. And we can get that wrong, and probably unlikely for quite some time that anything's going to automatically replace that, right? Because that's the thinking and the logic that really matters, save for our AI overlords in the future. Here's the second statement. The sky is uncaught TypeError cannot read property color of null at anonymous. This is broken. I don't think you would ever want to have this feature. I mean, unless maybe you were writing like ironic JavaScript poetry or something, but like, this distinction wasn't really clear for me until I worked with functional programming, because for me, this was kind of normal life, right? Like, you can't avoid this. This is what programming is. This happens all the time. It's called a bug, and you fix it, and you kind of move on. And the premise of functional was, yeah, you can. Like, you can just not have these in your life at all. And that kind of, I really struggled with. So the reason I struggled with that is because of this definition. Functional will not save you from semantic incorrectness, but it can save you from things that are actually broken. We don't necessarily need to have these in a language. The second thing that I wanted to side note on was this whole notion of functional. People say, oh, JavaScript's functional. That's not true, but the premise is that JavaScript has both functional features and imperative features. And in between those two kind of paradigms, there are actually some compromises. Yes, you can draw good ideas from both things, but ultimately, one of the kind of premises of functional is functions, in the mathematical sense where functions don't do things. If a function does something, we then define that as a procedure. So straight away, the fact that you can take imperative features and sprinkle them anywhere, you put yourself in a situation where there's compromises and FP practices really require discipline. So this is why, especially Redux is a good example of that. People who maybe are new to the React stack and haven't used Redux before and drag it in because they think that that's what they need as a baseline. And it turns out maybe they don't yet need that. Now they're doing all these crazy things all over the place and trying to manage all this kind of boilerplate for this alleged benefit of FP, while simultaneously having the ability to escape hatch and do their imperative stuff. And I think, path of least resistance, the temptation is really, really high to do imperative features. So I think my experience has been that functional features are really amazing. Learning them helps you think differently, but ultimately you're in a code base, especially under commercial pressure or time pressure, you're going to compromise and do the imperative things. In a functional language, as I define it, you have functional features and that's it. So there is no backdoor. FP practices are the default. You can't accidentally mutate stuff. You can't accidentally do effects because it's kind of constrained. So the premise is not to infantize a developer and say, oh, you can't manage this stuff, but actually to say, hey, maybe when we don't have certain things here, it actually helps us write better code, write faster with more confidence. And that's true of what I found in Elm. OK, enough talking. Shall I show you some code? OK, so like I said, I'm not going to go into super detailed examples, but I'm going to give you a basic counter so that you see a full, complete, could deploy to production piece of Elm code. And then I'm going to use that to talk about the Elm architecture that's powering things underneath. Does that make sense? Cool. So I'm going to step through it, and I'm really sorry. I hope that you can all see. Is that OK for everyone, or is it a bit struggly? Half nods. OK. So at the top of a Elm file, simply open a new Elm file, call it app.elm or whatever you want. We're going to put module main. Exposing the syntax for dot means that we're exposing everything in this file. We could choose to expose only certain functions if we were writing like a little library module. But in this case, we've said wildcard, just include everything. We're going to import some stuff from the core library. I'm going to import two things. From the HTML library, I'm going to expose 4 functions. Remember, like I said before, they're all functions. They don't do anything. They return values. So beginner program takes a bunch of parameters and returns a program value that Elm will run. Button, div, and text are all functions that take a set of arguments for attributes, a set of arguments for children, and then they return a virtual representation of what that markup might be. That's all I kind of need. And the onClick function will take a message type that I want to trigger, and it'll give me a attribute that I can put in an element. So in every Elm app you'll experience, at the basic level, we write 4 things. They are the only 4 things we ever write. So once you learn these 4 things, you can approach any Elm app and immediately know where to start and what to look for. So the 4 things are our initial model, which is our initial state, a type. We're going to call it message. You could call it whatever you want, but we're going to call it message. This is going to be, so if you know Redux, this is an action, so all the actions that our app supports. We're going to write, so they're the two models, or the two values that we're going to write. And then we're going to write 2 functions. One is an update function. And this update function will receive, at any given point in time, a message and the current model. And what we need to return back is the new model based on our business logic. So all of the business logic for an Elm app sits in this function. Just one place. Then we've got the view, and the view is very similar to what you might have seen in React, except here it's explicit. It explicitly takes in a model, and we will return some markup. So let's go and implement that. So for the counter, we're going to start our counter with a value of 0. Our whole model is just going to be a single integer. Our model could be anything. It could be a hash type with lots of things in it, which is normally what you'd get to in a bigger app. But let's just start with just plain old value. For the message type, we want to be able to, sorry, I didn't actually show you the button that we're, sorry, you're going blind. So this is the app that we're going to build. So you can +++ on the counter, minus, and we have no guards in our business logic, so you can go negative. Cool? OK, so if you think about that app, in terms of the actions we have, we really just have two actions. We want the counter to go up. We want the counter to go down. So we're going to just create two types here in the message type. So message is either going to be increment or it's going to be decrement. I'm not going to stress this too much because it takes a little while to kind of learn this concept, but you can kind of think of this as an enumeration for now, if that makes it a little bit easier. Or you can note that Boolean has exactly the same type signature. So type Boolean is true or false, where true and false are the actual values that get passed around. You don't really pass around Boolean. Does that make sense? So increment and decrement are two actual values. They're kind of like labels. They're labels that we can pass around, and they'll be type checked. So we can't put a label that doesn't exist somewhere that doesn't exist. OK, so our update function, usually 99 times out of 100, we will start with a case. And a case is, as you would expect, the message is of the message type. So we're going to case on increment. Well, if we're incrementing, if that's the message that we received, we're going to return model +1. If we're decrementing, we're going to return model -1. And our view is going to use our functions. So let's focus on this middle function first. So you can see that the divider has no attributes. So we're putting nothing in the attributes, just a plain div. And as its contents, we're putting a text node. So that's just a root text node with no wrapping. And we're putting a toString of our model. So our model is an integer, toStringed into the text version. That's going to be text node, so that's going to sit in the middle. Before and after, we're creating two buttons. The buttons do have attributes. One has an attribute of onClick decrement. The other one has an attribute of onClick increment. And then they have the individual text nodes that they're showing. And then all those values are wrapped in a div that has no attributes. And that's what we return back. Is everyone comfortable that they understand on a high level what this code does? Syntax aside for a second. This is the last line that stitches everything together. So Elm always looks for an entry point called main. And in main, we have to give Elm a program value. So it's a value that describes how our program functions. So what we're doing here is we are taking the beginner program, which is the function that we've got from the Elm core library, and it takes a hash that has 3 parameters or 3 attributes in it, a model, a view, and an update. So literally, the stuff that we've just written, the 4 things that we've written, save for the message type, we say to Elm, OK, well, this is what our state looks like. Here's the initial model. Take that away. Lovely. Here's the view function that I want you to run for me whenever there's a new model. And here's the update function that I want you to run for me whenever you get a message. So the net outcome of that is this little app. And as you can see, hitting plus is triggering that message. Minus is pulling it back down. Yeah, OK. Any questions at this point? All comfortable. All right, I'm just going to bang on the point a little bit. So that view function that we wrote takes a model, and it returns a value called HTML in Elm. It isn't actual HTML, similar to the way that React does it, because Elm has a virtual DOM implementation. So it's efficiently checking for changes and things like that and managing the DOM for us. We don't go anywhere near the DOM. We just tell Elm, well, here's what our markup should look like for that state you gave me. So that's always a new set of HTML. The update model works similarly. It gets a message in the current model. We do whatever logic we want, make whatever changes we want to a new model, and we give a new model back. We can't mutate that old model. So I'm going to try to visualize it again in another way, and hopefully just really sinks it in. So here's our Elm runtime, which we don't control. The Elm runtime happens outside of our control. We simply gave it our initial model, we gave it our update function, we gave it our view. So now we've compiled that, we've booted up our JavaScript in the browser, and our app is running. So we've clicked a button, which has fired one of our messages. Now remember, that markup can only have the messages that we defined in our app. If we typed any other kind of message there that was unhandled, that would fail at compile time. So the browser is going to give us a message type, and it's guaranteed that that's going to be a message type we know about. So the Elm runtime is immediately going to do 2 things. First, it's going to send that to the update function, call our update function, and get back the new model. And it's going to go, cool, I'm going to retain that model. That's the new model now. Then it's going to go, right, view function, here's the model, get me back that HTML. Great, I've now got that HTML. And it's going to do the virtual DOM diffing, calculate the DOM differences, and actually communicate that back into the layout. Everyone happy so far with that? Nods, but like more furrowed brows now. Hopefully furrowed, because you're thinking, well, this is really nice, Mario, but how do you actually do anything with the outside world? So like I said before, the guarantee that we have when we're looking at any Elm function in code is that it's not going to be doing effects. So say we wanted to write a little app where you pressed a button and it fetched a new GIF of a hilarious cat animation, right? So when that button is pressed, we would like to send an AJAX request or a request to a server to get a new URL, and we'd like to get that request back and change it. Well, actually, it functions in exactly the same way as the browser. So what we write in terms of our app doesn't change. We still only have 4 things. We have the model, we have the types of messages that we can expect, we have our update function, which has our business logic, and we have the view. Except what happens now is when that message type comes through, this kind of upgraded, so this is html.program, we were on beginner program, we've gone to program now, so the type signature changes slightly. Update function now returns 2 values instead of 1. So instead of just returning the model, it now also returns an array of what in Elm are called commands. They're values that represent a command that Elm may execute for you later. So you can kind of think of it like promises that you cannot resolve. There's no mechanism in Elm to actually resolve commands yourself. The only way to resolve it is to hand them back to the Elm runtime. So let's say we'd done this and our request has, we've asked for Elm to do a request for our cat GIF. Well, in the meantime, Elm goes, yeah, that's nice, but I got a new model, I'm gonna run the view, and we're gonna put that stuff back in the DOM. So that whole process happens instantaneously. Then at a separate asynchronous juncture, Elm may choose to take that command into what is called an effect manager. So Elm has an implementation of a certain set of effects that the language supports. HTTP requests are one of them. And it will execute that command. Now, when we issued that command, what we had to issue along with the command is an instruction to Elm of what message type we wanted to get back. And so then Elm deals with the busy work and the possible failures and the nils and all that kind of stuff. And it'll only give us back well-defined, conformed, guaranteed, actually okay messages if they happen to exist. Yeah, so what the effect manager will be doing is it'll be sending back a message. Note that this message and this one here are the same, exactly the same mechanism. Let's take it in isolation. So imagine that whole loop has happened and we've got our new DOM, and now asynchronously the effect manager has triggered a command for us. So there's been an event. Let's say we've successfully gotten back our HTTP request. So the message that we've defined, which is a message in our update function that accepts back the specific value that we're looking for, will get called for us. The same thing will happen again, just exactly the same route, like as if it had come from the browser. We actually don't know where it's come from. I mean, it could have come from the browser, it could have come from an effect manager. We only know by the semantics of the messages, the action types that we've implemented. Model and HTML view gets run again, and the DOM gets output. So that same mechanism kind of works through for both versions. That is the most complicated thing that I ever had to try and figure out with Elm. So I'm really hoping that unlocks a lot of the runtime. Perhaps my favorite thing about Elm is that it has the best pair programming buddy I've ever worked with, mainly because they have no attitude and they're never wrong. And it's just really, really pleasant. You don't have to talk to anybody. Like the compiler just kind of yells stuff at you. So I'm going to give you some nice canned scenarios first, just so you see the kind of quality of Elm error messages. Okay, so the first one I'll show you is this name. Okay, so here we've got soon. Here we've got an error from Elm, and this is how it would come up in your console. So you could have a live reloader going, and you save your file, and it's spitting stuff out, or I have it directly in my editor. And Elm has said, hey, I've detected an error. It's a naming error. I can't find the variable list.nap. You've lose list.nap. A list does not expose nap. Maybe you want one of the following, list.map, any map2, map3. So it's done a heuristic search on the name, which is really nice. So it not only does it tell you what's wrong, exactly where it's wrong, give it little indicators to highlight specifically on which area of the line it's wrong. It also gives you suggestions for other things. So this is a live code example that I've just reloaded. Getting a little bit more advanced than that, here we've got an if statement. We've said if n is less than 0, then let's return the string negative. If n is greater than 0, let's return the string positive. Otherwise, let's return 42. So Elm here is telling us, well, you've got a type mismatch here. The second and third branches of this if produce different types of values. The second branch of this type is a string, but the third is a number. And then it gives you these hints. These are the best thing by far. So that's the nice can scenario, which is what normally gets talked about in talks. So I figured it's probably better to show you where Elm really shines in the worst possible scenario. Luckily, I have the worst Elm code base known to me, which is my own code base. And I'm just going to go and arbitrarily change something in the application that you're all using on your phones, to try and just give you a little bit of a sense of what it's actually like to do mass refactorings in Elm. So here we've got a foreign code base that we've never been in before, and it's got like tons and tons of code. It has no tests, like nothing, like just, like absolute horror. Someone at work has like gone full crazy on Elm. They've just built all this stuff and they've quit, right? Now it's your job to deal with it. And you're ready to like quit your job, and you're like on Stack Overflow looking for other stuff. And you're like, all right, I remember Mario said some stuff like I should recognize this Elm app. You go app.elm, I'm gonna start. Okay, so we got a program with flags thing here, and we kind of see like, okay, init, update, and subscriptions, and some stuff is here. And we've kind of got this types thing here. So it seems like types is, let's say we need to extend this app, right? We want to add a new page to the presentation software. So we go, okay, cool. Well, we know that in Elm, to add a new page, we probably need to find a type for that page, or we probably need to find the actual core message type that represents all the actions that can happen and add something there. So say we go into types, we'll look through, we've got type page, type aliases, we've got things, here we go, type message. We go, cool, so this is all the stuff, actually all of the things that this app does. There's nothing this app does that isn't here. Like, let that sink in for a second. It's a code base that you've never touched before, and immediately you already know everything that it does. So let's say we go, okay, my new awesome feature is the new label. Like when you click a button, it's going to trigger my new awesome feature, which is going to be amazing. And we save this, and what we get from Elm basically now is a pair programming buddy that intimately knows the whole code base and has in a split second gone through and checked every single file, every single include, anywhere that this type might be used, and immediately started coming back with errors. So the very first error that it's given us is saying, well, your update function, which is in another part of the code. Remember, the update function is the main function with all our business logic. Saying that update function doesn't cover this new feature that you have. You need to go and add that in there. So we'll say, okay, cool, where's that update function? It's quite a long update function, so we've got to scroll to the top. Like I said, it's like the worst possible code. Okay, so it says state.elm, and here we go, we've found our update function. So let's kind of scroll to the bottom of it, to all the various things. Remember, like worst possible code. My awesome feature. And let's just say we're going to return the model as is, and we're going to turn command.num. We're just not going to do anything, right? It's going to be a no-op. Now it's saying, well, can't find pattern my awesome feature. Why not? Because it's called my new awesome feature. Yes, thank you, pair programming buddy. I've made that change now, and Elm is saying, okay, that's pretty good. That's good. That is all you needed to change. Nothing else in the code will break. You didn't make any other side effects. Nothing else depends on that new feature you've added. You are 100% A-OK to deploy this to production. So that, for me, is like chalk and cheese difference to the kind of development that I have day to day. So much so that I'm finding it increasingly more difficult to program in other languages without these guarantees, just because the level of uncertainty that you gain by working in a language like this kind of really decreases your confidence in other languages. So I find myself now when I interop with JavaScript and Elm and I'm working with JavaScript stuff, with Elm, you write stuff and you compile it and it's wrong, and you change it and it's wrong, and you change it again, Elm's like, no, you're wrong, and you fix it and it's green, you're like, it looks like it's pretty good. And in JavaScript, you change something and you're like, where's the thing that tells me, maybe it's okay, I don't know. Like, you've got to potentially now go write tests. Do your tests cover every single case? Potentially not. So the wrong and broken difference, that kind of broken bit just kind of disappears, but the wrong bit is still your responsibility. Everyone somewhat satisfied with a real life example? Okay. Cool. Very quickly, ending off with some high level stuff. So Elm packages have Auto-semvar. So again, when I talked about the nice side effects of having enforced purity and side effect-free code, Elm can look at your library and all the type signatures that you have exposed. If you have changed no public interfaces, Elm will minor version increase. If you have added a public interface, it will the middle version increase. And if you have removed a public interface, it'll major version bump your code. You can't change your own version numbers in Elm packages. It just does it entirely for you. The flip side of that is when you're pulling down new package updates, Elm can automatically, or you can safely, pull in minor and intermediate versions because you know that they haven't, fundamentally, they shouldn't have changed, they wouldn't have changed any of the interfaces. They may have changed some behaviors, but generally it's a lot safer. And then if you're dealing with a major change, you know that something's going to be removed. Even still, bringing that package in with a major change, you're pretty happy because the Elm compiler will then immediately tell you every single place in your code base where your usage of that package is now broken. So you still have the protection and optional choice on whether you want to engage in that work or not. But when you do upgrade, it gives you like a bucket list of exactly how to upgrade, which is pretty awesome. The Elm packages site, if you want to kind of look at the kind of packages that exist in the Elm community, they're on packages.elmlang.org. Yeah, check it out. There's not much more to say there. Compiling Elm, so I haven't talked about how Elm actually works in terms of compilation. So like I said, even though it has all this library stuff, it is fundamentally a separate language that has its own runtime. So it's got its own compiler. So you write a bunch of Elm files, and they run through the compiler, and you get compiled JavaScript that includes both your code and the runtime and all the libraries and everything to do with it all kind of packaged up. If you're in a project that has JavaScript files already, you're probably going to want to pull in Elm incrementally into certain bits to try it out or to have kind of some interop. So the very, very simple way to do that is through Webpack. Webpack has a Elm Webpack loader, which will simply allow you to require Elm files directly and then mount that Elm app to whatever node you actually want that to attach to and then run the rest of its stuff through. How do I use Elm at work? The answer is gradually. There's actually a blog post by the author of Elm himself. His name's Evan. And he talks about the incremental approach and also what he's seen in his experience of the number of years that he's been improving Elm for Elm projects that have succeeded. And yeah, generally the premise is that you take a small area of an existing app, or if you're starting from scratch, if you have that luxury, and you can just try Elm out in a very, very small section and experiment and see if it meets your needs and if it works well enough for the domain that you write in. And then if it does, you simply just take more and more chunks of that tree or put Elm in multiple places around your app. So for those of you that are using React, there's kind of like a canonical example by Evan himself of React Elm components. So very simply, you're importing the Elm wrapper for React Elm components. You're importing your Elm app from wherever it might be, like the compiled code, and then you can just put that straight into a React render function. This is a very simple example. There's more complicated examples where if you want to pass some values for Elm initially, or if you want to actually talk to and from the Elm application. But all of this is like a 20-line wrapper. It's really, really simple. So just with plain JavaScript, you literally, if you're using the Elm Webpack loader, you're requiring that JavaScript that you've written, and you can just embed it to a node. That's the only attach point to get started. Cool. Caveats. General purpose programming language gets kind of thrown around a lot. So it's something that I got cut on, so I kind of want to put out there. Elm doesn't run on the server side yet. It's not a server-side language, and it's not a general purpose language. You could run it on the server if you really wanted to. In 0.19, the next version, there may be some server-side rendering stuff, because a lot of people have been asking about that. But there is a really, really good document about general purpose language, written by Evan, that I would recommend reading if that kind of infuriates you for some reason, because it's actually really clear and articulate on why this kind of premise doesn't really exist. So, we might say Python is a general purpose programming language, but you're not going to go write assembly in it. We might say C is a general purpose programming language, but you're not going to do web development in it. So general purpose languages do still have specializations. So Elm is the same in that sense. Its specialization really is to be really awesome at front-end apps. Fiddling with a DOM, you're going to have a bad time. If you're really, really convinced that you really, really need to fiddle with a DOM, or you have some application that's for some reason doing something with external libraries and pulling in markup and all that kind of stuff, that is not something that Elm allows or is any good at, really. You can still achieve what you wanted if you talk through ports to some JavaScript kind of interrupt, but on that side as well, JavaScript interrupt is really, really strict. In order for Elm to preserve those kind of guarantees of runtime safety and not exploding on you, the way that it talks in and out of JavaScript is also through a really strict typed interface. So it makes sure that the types that come back are actual types that your app can handle and keeps anything else out. So kind of all the JavaScript errors stay on the outside and the Elm stuff stays pure. And yeah, this one's a little bit cynical, but you legitimately may be more frustrated with other languages, at least I have been. Cool. Thoughts after 2 years of functional programming. It's not a silver bullet. I'm not claiming that this is the solution for all problems. Like I've said before, I'm not suggesting we go to Linus Torvalds and say, hey, let's rewrite Linux in Elm. But I think if you're doing web development and you're writing web apps, which is specifically what Elm is engineered for, I think it trades off for better problems. The constraints that it gives you, it's kind of like Lego. If you've played with Lego as a kid, you probably didn't think, man, I really wish I could just put glue and wood sticks and cut the Lego pieces in half, right? Like you just kind of go, they snap together and suddenly you can just build all these kind of things. So for me, FP is that same kind of thing. I don't see the type safety. I've never felt it to be a restriction. It's just been kind of like an enabler. But if you really, really need glue and sticks, well then use glue and sticks. I'm yet to see a broken runtime. I haven't seen one yet. There are various edge cases that can cause them. You can look them up on the Elm Lang tracker. I think they've gotten them down to like 4 or 3 now. Elm reveals your mistakes. So as part of a previous talk, I talked about why Elm made me realize how terrible of a programmer I am. It's actually a positive because it improves your code overall, but it kind of does show you, like I said before, it lowers that confidence that you have in other languages because it increases your visibility of just how much you're not seeing, that you're not catching. And refactoring is really awesome. Before the last presentation that I did this live talk with, I decided to change something from a single field to like an array. Like I had a 1 of something and I wanted to have a multi of something, and I changed it and it broke the whole code base because my whole thing had been built with a premise of a singular relationship. And 15 minutes before the presentation, I was like, yeah, why not? Let's dive in. Managed to get like all the stuff checked off and all changed and compiling and deployed it, and it went flawlessly. So my experience with that has been that at a baseline level, in the worst possible scenario, writing the most terrible code with no tests, you still end up, in my experience, better off than other languages that don't have these guarantees and you do have those kind of tests. Okay, further reading, watching. The Elm guide is kind of like the canonical intro. It'll teach you all the stuff that I've violently skipped over, like actual syntax and the types of values that are available and some of the library functions. A lot of this talk, I've kind of ripped bits and pieces out from Kevin Yank, who does a much better and more eloquent job with much nicer slides. So check out Developer Happiness on the front end with Elm, especially if you also work with Rails, you may find that interesting. And then two talks recently that I think really address two problems that kind of people run into when they come to Elm, because it's such a different paradigm, is your app gets larger and larger and you want to scale it, or you start with a file, and like me, I kind of started with my first file, and once it got to 100 lines, I was like, oh, this is bad. 10 files and like modular structure and all this kind of stuff. And so Evan talks about why that's the reasons that we do that in other languages aren't actually present in Elm. So it doesn't make sense to do that. So he talks through a really beautiful example of those kind of assumptions and how they fall over in the life of a file and growing kind of modules out. And then Richard Feldman talks about scaling Elm apps to a much larger extent. Richard works at a company called NoRate Inc. And I think it's 200,000 lines of Elm code in production they have. And their claim is that they still haven't had a single runtime exception. So I think that's pretty cool. So if you want to say either of those kind of things, take it from the horse's mouth there. That's all I've got. Thank you.